Hello, my name is Joel and I'm a part-time instructor at Kazo Technical School. And today's video we shall be looking at Tig Welding. So what is Tig Welding? Tig is an arc welding process and it stands for tungsten inert gas. And this is a welding process where we use a tungsten electrode which is non-consumable and it is shielded by an inert gas. So let's look at the process in detail and compare it with other welding processes. So now let's have a look at some few differences between the welding processes. So this is a TIG welding torch and it has a switch. Whenever I'm welding, I always engage the switch, and this is the major difference with TIG is that electrode used. This is a tungsten electrode. It's a rod made out of tungsten, and we normally use tungsten because it has a high melting point. And when I'm doing any welding, there is always shielding gas which comes out of this cap. That's the major difference between TIG and other processes. So this is how a TIG torch looks like. Let's have this is now a MIG welding gun. It has a switch just as a TIG welding, but the major difference with this is that the wire is fed through the machine and it comes from a wire spool. So this is a MIG welding gun. And the other process that is most commonly used is shielded metal arc welding, which utilizes these welding electrodes. And these electrodes have a core wire, which is this exposed wire, and it is covered by a flux. And this is what does the shielding during the welding. So this is a 7018 electrodes, but the major difference is that this has a flux which is coated on the bare wire, and on the TIG we use shielding gas which is normally argon. And when it comes to MIG welding, it is also shielded by gas, most times argon or carbon dioxide. So those are the few differences I can point out for now, especially in terms of the torches. They look different. So now let's look at the setup of TIG welding. So right now let's have a look at the setup of TIG welding. So first and foremost, as we are saying, TIG, we utilize an inert gas, and the most commonly used gas is argon. Sometimes some people use helium as a mix. You can also use a gas mix. But here we have an argon cylinder, and always when you have a cylinder like this out in the open, you should make sure that it's chained to something. Right here we made a stand for a cylinder, and it is securely chained. So in case anything happens, you don't want to have any problems with the cylinder. So we get this is a hose that feeds the machine with gas, and it connects to the back of the machine, which is what I've connected here. And whenever we press the switch on the torch, we always get that gas shooting out of the torch. So first of all, we set up the gas, and when you come to the front of the machine here, we basically have two connections, or three. One is for the ground clamp, and this clamp connects to the table, and it's connected to the positive terminal of the machine. This part here is for the switch connection, as the sign shows here. Then the next is for the gas, as well as the negative polarity of the welding torch. So when you are doing TIG, since we are going to be demonstrating on stainless steel, we need the direct current electrode negative, or abbreviated as DCEN. This is where the electrode is connected to the negative terminal of the machine, which is the setup we're having now here. And so next, the ground clamp connects to the body of the table where we're going to do our welding from, and the negative is the one connected to this torch. So a TIG welding torch is made up of a back cap, the tungsten electrode itself, the collet, the ceramic nozzle, and the collet body. So first I mount the collet body, followed by the ceramic cap. Then I mount the collet, and this collet should always match the size of the tungsten electrode I'm using. Then I have the back cap to secure the tungsten. Closing them out. So when you're doing TIG welding, we always hold the torch in one hand, and we manually feed in the filler material. This is TIG welding wire, and this is stainless steel. Normally when you're welding, let's say stainless steel, you should always match the filler material to the metal you're welding. So one hand holds the torch, and the other hand is used to feed in the filler material, which is also one major difference between TIG and, let's say, MIG and shielded metal arc welding, is that you feed in the filler material yourself, whereas for MIG welding, the wire comes from the machine itself through a wire spool. So some of the advantages of TIG is that it offers you a lot of control. Since you are the one who operates both the torch and the filler material, you have a lot of control, and it also delivers very high quality beads. So if you're looking at quality, TIG is a very good process. And one major disadvantage of it, for example, out here in the open, since we're utilizing an inert gas, most times when air is blowing around, it tends to blow away the shielding gas, and you tend to get defects in the weld. So that is one major disadvantage. It's like you can't easily use it out in the open. So you always have to be in a place which is indoors. That is one major disadvantage of TIG. So let's set up and do some welding. So before we start doing any welding, we always make sure that we sharpen this tungsten to have better control when welding. This tungsten has to be sharpened to a point, and we have different types of tungsten. Right now I'm using the red type of tungsten, but in my experience, when you're welding stainless steel, the red tungsten works, rather all tungstens work for very well with stainless steel. But when it comes to aluminium, then we normally go for the green tungsten or pure tungsten. So right now I'm going to be grinding the tungsten, and safety first. Since I'm operating the bench grinder, we have sparks and have high levels of noise. So I have my earplugs. I also have my safety glasses.